happy to be here to make a presentation on what we are doing together with the Dilmah and the University of Peradeniya. So then, I want to make a special note as well. So then Dilmah has been giving all the support with, that we have been conducting with the University of Peradeniya, and I will brief about what we have been doing with respect to the topic highlighted today. So then my presentation is going to be basically I will discuss about, you may have heard of, or you know what is nitrogen, why all of a sudden, it's not all of a sudden, the interest on the nitrogen pollution came up in a big way, and also what are the major sources with respect to nitrogen issues, and what we have been doing, and what we should be doing, and what is the progress we have been achieving with respect to what we are doing. So then you know that there are about 94 naturally occurring elements in the nature, and human body consists 61 of them. And when you think of 61, only 6 is having 99%, the oxygen 65%, with the body mass, oxygen 65%, carbon 18%, hydrogen 10%, and nitrogen around 3%. And the rest is, even though we see that we have bone and things like that, high amount of calcium, is actually around 1% calcium content, and also the phosphorus 0.6. And the rest, all these 6 components, 9% of the body mass of of the human body, and the rest all is going to be around 1%. So when you think of the nitrogen, we know that 78% of the atmosphere is nitrogen, and you and I inhale per day about 11,000 liters of the air we inhale. So then in that 75% is nitrogen, but none of that cannot be taken into the body. So nitrogen, dinitrogen form is inactive, and it is no use with respect to food production or the any living beings related functions. So as I mentioned, this because this dinitrogen is very inactive, it has two atoms bind with the triple bond. So therefore it is because of that structural arrangement is inactive, used for the biological related activities. So then this, in order to use this has to be converted into reactive forms, right? There are different related reactive forms, then they only be used in the and also the other living functions related activities. So in order to convert this nitrogen into reactive forms, either nitrogen has to be oxidized or reduced. So then there are different species of nitrogen, reactive nitrogen. So then inorganic reduced forms are the ammonium and ammonium, and the oxidized form all NOx, nitrate, N2O, nitrous oxide, like that. So then again, once they fix, there are inorganic forms, AIMs, amines, proteins, and things like that. These are the active, reactive forms of nitrogen in the nature, right? So this has to be produced. Otherwise, it's not, what is available in the soil, with the rock and things like that, very minimal. So then main, the sources or the process producing these are the, there are several ways. One is natural. Natural fixation is happening in the nature. Lightning, you have heard this, with the lightning, nitrogen is converted into nitrate, and you see that even with the lightning farming, I mean, growth of the crops are going to be increased like that because of the production of reactive nitrogen. And also in nature, a group of organisms are there where nitrogen of the atmosphere could be converted into ammonium form using energy produced by the plant through the photosynthesis process. That type of organisms are called mainly rhizome, all leguminous, and also the pre-living fixers are there where the direct conversion. Another thing is weathering of mineral soil. It is a slow process, but with that, the amount release is going to be to the nature is very much limited. All other like lightning and also the leguminous, so then rhizobium, they fix nitrogen. And the anthropogenic fixation, that is what actually nowadays in large scale the reactive nitrogens are produced. The manufacturing of fertilizers, all urea, nitrogen-based fertilizers manufactured, they are very expensive process because a lot of energy has to be used to convert, and also the lot of industries are being used, burning of fossil fuel and waste. Those are the sources generate reactive nitrogen. So then again, like I mentioned, this is nitrogen. If reactive nitrogen is not there, I mean, you and me, I mean, nothing could be seen in living forms in the atmosphere, right? So therefore, reactive nitrogen is very important. All protein, enzymes, DNA, all are nitrogen based. So I mean, if you take the largest enzyme in the nature is Rubisco, where the photosynthesis is taking place. Those all are proteins, and all proteins are nitrogen based. Nitrogen is an essential component in this production process. So then again, if you go with the natural fixation in the nature, world population is going to be half of today, right? Because of the Green Revolution and invention of the inorganic fertilizers, food production increased rapidly. As you can see, after 1950s, 60s, where the Green Revolution came into practice and the population, linear increase of the population is resulted because of the food availability, food production, because nitrogen was one of the limiting resource for the plant production, right? Those who are cultivating crops, you may be knowing the importance of nitrogen, how significant the nitrogen with respect to food production. So then I want to mention in here, so then right now is producing about, 2020 records, 181 million metric tons of urea. Right, again from that, about 125 million metric tons are used in the Asian region. Asian region is the number one with respect to use of, because one thing, highest population, agricultural base, because of the highest amount of is used in the Asian region. Therefore, losses to nitrogen is highest in the Asian region as well. So then, positive things, what I mentioned, it's very essential for the production. And negatives, right, all these reactive species are very important. If you release them to atmosphere, and if it is going to be free in the nature, a lot of negative things could be happen. For example, global warming, nitrous oxide, emission of nitrous oxide, and also the NOx, the ammonia pollution, all are going to be impact on many ways in ecology, human health, diversity, and causing numerous, and also the eutrophication of water bodies and pollution of soil. So those are the negative impact if you misuse, right? If these species are going to be released unattended, so then a lot of negative things could be happen in many ways. So then again, highlighting the same ammonia eutrophication and a lot of now respiratory related, even the carcinogenic, the effect is there with respect to NOx and also the ammonia, global warming, water blue baby syndrome, those things are the direct nitrogen related negative impacts. So then the Sri Lankan status, so we have been, in 1940s, we were not using fertilizers, our population is, during that time, though with the 6 million, we were importing 60% of the rice requirement to the country. Because of the evolution of the agricultural practices, introduction of new improved varieties, and also the management practices, and also we are also started to use inorganic fertilizer. It started from like 1970s, 80s. Now you see this is the importation of nitrogen fertilizers to the country. There is a sharp increase, but 2020, then the banning has impact, you know that. So then right now we are coming back to what we have been from 1950s, 2015s like. So then importation is there. Another important thing, with respect to nitrogen related fertilizers, so though we spend a lot of money on this, right? The usage by the plant is about less than 30 to 40%, right? You apply, but plant take, we harvest as yield, only about 30 to 35% of the applied. Rest is going to be lost in the system. So then if you take monetary wise, huge loss, because we invest huge amount of foreign exchange to import, right? Because we are importing the straight fertilizer, not the improved version, and also to a certain extent, I don't like to highlight this, sometimes not with the good quality as well. So because of that, efficiency of the usage is going to be less, so therefore wastage is going to be high as well. So this is what the trend, anyway, agriculture has to be expanded, population is going up, we have to use more and more input, right? So then losses related to this is going to be improved, increase as well, if we are not taking certain measures to minimize the losses. So then this is what I mentioned. In most of the cases, nitrogen use efficiency in the agricultural systems is in the range of 20 to 40 at present. With the present day nitrogen type of fertilizers we use and the management techniques. So then again, we have observed the ammonia, nitrous oxide, NOx, so increase over the years in the country, and all are in the increasing trend. They are all increasing. So then it is going to be for increasing further, in the future as well. So then therefore we have to make certain decisions what to do in order to address this issue. So then they are all in the rise. So then when you think of the sources where the emission is going to be, and it is mainly from the agriculture sector, right? Because we use all these nitrogen related fertilizer, that is the main source where all these reactive nitrogens are going to be lost to the environment. Agriculture and all the other sectors are going to be, you can see the proportion, but about 85% of the ammonia emission to the atmosphere is from the agriculture sector, mainly fertilizer and also the animal husbandry, all dairy, poultry. So then they are dung and urine, they are source of ammonia emission to the atmosphere. And when you think of the nitrous oxide, again, 61% of the nitrous oxide released from the agriculture related activity. You know, when you think of the global warming potential, if you take carbon, we know that carbon dioxide is a the greenhouse gas, nitrous oxide gas, but when you think of the global warming potential, molecule of nitrous oxide, it has 2 times to 300 times global warming potential than the CO2, carbon dioxide. So then, it's like releasing 1 molecules of nitrous oxide to the atmosphere is equal to nearly 300, right, molecules of carbon dioxide to the atmosphere. So therefore, I mean, this is nitrous oxide is very potent with respect to the global warming compared to other gases. For example, if you take CFC, it is going to be 7,000 type, but different gases are having different global warming potential compared to the carbon dioxide. So then again, you see, I mean, in Sri Lanka, when you think of the GHG balance, so the majority of the nitrous oxide coming from the agriculture sector is going to be a very significant number. And then all the other NOx, NO2, NOx, so then agriculture sector is not that the contributing, it's actually mainly 46% coming from transport, power, like to the NOx emission. So when you think of the, so then again, once you apply, certain things are coming, goes to the atmosphere, and then what is dissolved in the soil water goes down, and one of the nitrogen species dissolved in the water is nitrate. Once the nitrate is dissolved, they goes down and then pollute the water, and all the eutrophication, when you see all these tanks in the dry zone, you see a lot of Japanjava, Iconia, and also even Bear Lake, you can see when the nitrogen content is increased, so then a lot of algal and blooming is taken place, causing eutrophication, right? So is showing how the nitrate concentration of different region in Sri Lanka. And you see darker the area, that means groundwater is already contaminated, and it goes beyond the WHO recommendation, and maybe in certain regions like Kalpitia, even certain Jaffna, that certain regions are not, I mean, the water is already polluted, it's not suitable for drinking as well. But there is a seasonal pattern as well with respect to monsoon rain. So then again, when you think all these taken into account, usage, management, and things like that, so the Sri Lanka is ranked 131 out of 180 countries with respect to sustainable nitrogen use. That means, I mean, we are not in the correct directions. We have to take a lot of precautions to come near to get into a lower number. So with respect to sustainable nitrogen management. So, and again, like I mentioned, I mean, this color, this different like shading shows you how significant with respect to NO2 and also the ammonia emission in the Asian region. Darker the color means reddish color. That means we are identified as a hotspot in the Asian region, identified as a hotspot with respect to nitrogen-related pollution. So then a lot of global level initiatives are taken in order to address this issue. So then due to some reason, I don't know, the headings are not appearing. So then like since the Asian regions has been identified as one of the hotspot, and then actually the presenter going to make the presentation after me, Professor Mark Sutton, took the leadership in developing a collaborative project with the South Asian region, and we were able to get the funding from UK government and initiated South Asian Nitrogen Hub project, where all countries got together and looked for solutions, possible solution in possible areas, like even starting from policy, management, modeling, like, I mean, different areas to tackle this issue. So in there, actually, countries got together. There are many institutes providing the technical support. So then we are one of the, Sri Lanka is the leading country involved in the sustainable nitrogen management project with the South Asian Nitrogen Hub. So then in this whole program, there are key research areas, the building nitrogen policy arena for South Asia and nitrogen solution to, there are 4 different research programs. Under that, different work packages are there. Actually, my colleagues, Dr. Gautami, Ajinkan, I mean, they will be presenting about what specifically doing with respect to lichens under this South Asian Nitrogen Hub project. There are series of experiments are being carried out to tackle, to find solutions to different management, genetic solution like that. So then, when, I mean, again, if you take so I will highlight few of the outcomes. One of the key aspects is to analyze, collect all the policies related to nitrogen management, and then identify, identified based on the different sectors, and then review whether these policies are adequate or whether gaps are there, and whether amendment is needed or new policies are to be made for respective sectors. So then we found, I mean, we collected out of hundreds, we collected 115 related, nitrogen related policies, and then based on the type of policies, we categorize like agriculture related, energy, food, industry, land use change, waste, like that we identify how many policies, direct, indirect and multiple coming under different sectors, and then we start the negotiation with these respective ministries, department, and then we are in the process of reviewing those policies to see whether amendment is needed in order to tackle the nitrogen issues in the best possible way. So this is ongoing, but anyway, we have achieved great success. We published the book called National Nitrogen Policy Report for Sri Lanka. Anybody who wants, is this available in the online. So then is a document giving the specific information regarding all policies, 100 policies and their guidelines, act and everything, right? Compiled into a document. Anybody who wants to get more information. So then second is, again, I'm from the agriculture faculty of University of Peradeniya. So our main target is to find ways to improve the nitrogen use efficiency of agricultural systems. So what type of fertilizer, improved fertilizer could be used to enhance the fertilizer use efficiency while enhancing the productivity, whether we could reduce the use of fertilizer. So then, and also for that actually, we start to do the capacity building of the, identify the capacity of the farm families, their knowledge base, whether, interesting thing, and they know that most of the farmers, we do the survey, they know that application of insecticide like that, they have negative impact, but application of fertilizer, they don't think that there is any negative impact because they don't see it immediately, like in the case of agrochemicals, other like insecticides. Actually, I want to highlight the PET. Okay, this is what, in brief, because alarming is there with respect to timing. So once you apply the urea to the soil, it is first hydrolyzes into ammonia, and then this is going to be, if you leave it, and certain group of soil activities start to release ammonia into the atmosphere, and then it is going to be converted to nitrate by the set of microbes, and then nitrate could be leached as nitrate, or again nitrate is converted into nitrous oxide by another set of group of microorganisms, right? Anybody interested, I can give details regarding this scientific basis of this. So then, in order to arrest this, right, if we can delay the hydrolysis of urea or microbial activity of conversion to ammonia and the nitrate, so then you can retain the applied urea in the soil longer period, making available for the plant. So then there are several ways of doing that. In this experiment, we are doing field trials in addressing, testing those new improved technologies to find what are the best ways to improve the nitrogen usage efficiency with respect to fertilizer management. And we have conducted series of experiments for rice, and we have conducted series of experiments for potato, and we found, right, we can cut down about 30% of the Department of Agriculture recommendation with these all amendment type of improved type of fertilizer management. So that is actually, I mean, we can clearly identify that as a very promising outcome of the South Asian Nitrogen Hub project. So then even potato, even rice, and I mean, we can repeat the same for other crops as well. So the nutrient use efficiency could be increased with the fertilizer amendment with respect to the nitrification inhibitors amending with the fertilizer with those type of advanced technologies. So then again, from the Batalagoda, we took the rice varieties, about 40 different traditional, all improved, new improved, hybrid line, and we see when they grow in a low nitrogen status, what are the varieties which are going to be performing better. So then we identify those varieties and doing the genetic engineering, like identifying genetic mapping, why certain varieties are performing better under low nitrogen, why not then, I mean, use that ability to improve further in the varietal development programs. That activities are being carried out with the Plant Biotechnology Center of the University of Peradeniya. So this is one of the key area we are focusing, identify genetic material or varieties which are capable of using less nitrogen while producing high nitrogen. That means high nitrogen use varieties, the identification of that. So then in summary, so then I have already highlighted the nitrogen use efficiency is less than 40%, and all are going to be cause a lot of negative impacts. So then we have to find ways to minimize the losses while improving the efficiency. So then the global level initiatives are taken, like I mentioned, and there are now Colombo Declaration. Actually, Professor Mark Sutton is the father of this South Asian Nitrogen Hub project. With his initiatives, we have a Colombo Declarations with the objective of that is by 2030, nitrogen losses from all sectors reduce by 50%, right? So then follow-up UN resolution is there. So there also the main objective is to, I mean, look for ways to reduce the nitrogen losses, and we identify, I mean, it name as sustainable nitrogen management. So then there is a UN policy now, UN resolution now. So then all countries has to sort of pay attention to adhere to that. So then we introduce, with respect to our findings, all introduce advanced efficient fertilizers, and judicious fertilizer management systems are essential. We can say with our findings, we can cut down the fertilizer use by 30%, the DOA recommendation, Department of Agriculture recommendation, by incorporating advanced type of fertilizers. So then even recently certain private companies who release fertilizers where the nitrogen usage efficiency is high. So then that is being developed now. And again, capacity building of the stakeholders is very much needed, right? People don't know the negative impact of the nitrogen pollution, nitrogen application and related pollution. And also introduction of appropriate policies and regulations are very much needed. And also with the, since the Sri Lanka forwarded the UN resolution of sustainable nitrogen management, United Nations Environmental Protection Agency asked us to do the National Action Plan process of developing the National Action Plan for Sri Lanka on how to go for sustainable nitrogen management. We all, probably your help is needed in different sectors to come up with viable solutions, viable ways to go for it. Okay, this is what I mean, may have taken a bit of more time, but thank you very much.